Practice problem on mathematics of motion. Out for a morning drive at 25 miles per hour, which is 11.3 meters per second, a squirrel suddenly leaps into the road. You brake at negative 2.3 meters per second squared for 1.21 seconds to avoid the squirrel. How far did you travel while braking? Then you accelerate at 1.5 meters per second squared after the squirrel is out of the way. How long will it take you to get back up to the speed limit? Let's take a look at a diagram of the event. There are two parts to this problem. First of all, you're going at a constant initial velocity of 11.3 meters per second. Once you see the squirrel, you brake and have a negative acceleration rate of 2.3 meters per second squared for 1.21 seconds. The question there is, how far does your car travel during that negative acceleration time? After you've done that, your car's speed is obviously lowered. Then you want to hit the gas and accelerate at a rate of 1.5 meters per second squared to get back up to the speed limit of 11.3 meters per second. And then you want to know the time it takes to do that, to get back up to that speed limit. Okay, so let's first work on the braking to avoid the squirrel part of the problem. Here we know you start at an initial velocity of 11.3 meters per second. You're then going to have an acceleration rate of negative 2.3 meters per second squared, meaning you're going to lose negative 2.3 meters per second of speed every second. You're going to do that for a time of 1.21 seconds. And we want to determine how far did your car travel during that braking time to avoid the squirrel. See if you can solve this on your own. Hit pause. Okay, so I would look at delta x equals VIT plus 1 FAT squared. We have all that information of 11.3 meters per second, and we accelerate at 1.21 seconds at that rate of negative 2.3 meters per second squared. Again, for that same time of 1.21 meters, or 1.21 seconds squared. All right, that's going to reduce to 13.68 meters minus 1.68 meters with some rounding there. So we're going to get about 12 meters it took our car to brake to avoid the squirrel. Now, thinking about the next part of the problem, it'd be nice to figure out what our final velocity is at the end of those 12 meters. And if I look here, I have my initial velocity, my acceleration rate, and how long I accelerate for. So we can apply the definition of acceleration to this to determine the final velocity. See if you can do that now. Hit pause. So here's our definition of acceleration, and negative 2.3 meters per second squared. That's our final velocity, which we don't know, minus our initial of 11.3, and we braked for 1.21 seconds. So a little cross multiplication here and some addition, we will get a final velocity of 8.51 meters per second. Let's look at the last part of the problem, where we accelerate back up to the speed limit of 25 miles per hour, or 11.3 meters per second. Let's look at our given information again. We're going to accelerate at a rate of 1.5 meters per second squared now to add velocity back. If you recall, our velocity there at the end of the braking is now our initial velocity, which is 8.51 meters per second. We want to get back up to the speed limit, or 11.3 meters per second, and we want to know how long that's going to take when hitting the accelerator. Take a look at that given information and see if you can determine the time. Hit pause now. Okay, so if we put in our definition of acceleration here, change in velocity over time, and that's 1.5 meters per second squared will equal our final velocity, which we want it to be back up to the speed limit, or 11.3 meters per second, minus the 8.51 meters per second we were down from braking, and we want to figure out how long that takes. A little subtraction, cross multiplying here, or dividing rather, and we'll get a time of 1.86 seconds. Thank you for watching, and see you in class.